Um, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera to Dr. Fuad. Uh, Me and my group is going to present our last group project for computer architecture and organization. And this is our group members: Ang Chuhui, Kwan Ziran, me, Amirul Irfan, and lastly Muhammad Hafiz. So, the purpose of this project is to benchmark our CPU and get the result for the CPU speed, the memory speed, and the solid state drive reading speed and transfer speed.
Alright, so right now we're going to the part one CPU benchmarking and performance analysis using free tools. Alright, so the problem statement right now for our project is to involve CPU benchmarking and performance analysis. So basically, we are using the CPU benchmarking like Geekbench 6, CPU set, and mini tool partition width. Then the CPU benchmarking is the process of running a series of tests to measure the performance of a computer CPU. So whether the CPU is good or bad, or it is slow, or it execute the program very fast. The primary problem address is to understand the performance capability of different CPUs, as I say just now. So under it is we have various workloads. So for example, we have the low load for the daily use and medium loads for the office use, or even opening multiple applications, and the heavy use such as playing games, edit videos, rendering videos for, and we are going to test these capabilities using free benchmarking tools. Alright, so the aim of this project is to evaluate and compare the performance of different CPUs. So we are going to use four different computer with different CPUs and specs, memory specs, all of that by using a set of free benchmarking tools. Then this will involve performing detailed analysis and presenting the results in a comprehensive report and presentation. So right now for the objective of the for this part A, we are going to understand the CPU benchmarking. So the CPU benchmarking is to gain knowledge about the principles and types of CPU benchmarks. So we need to learn all the how does the CPU benchmarking works, and how does it the outcome. After that, we are going to for the tool selection and usage. So as I said before, we are going to use CPU Z for studies all the computer specs, and for the benchmarking, we are going to use Geekbench 6 for the CPU stress, and for the partition wizard is for the test the performance of the memory, and for the last one, we are going to create three situation: low load, medium load, and for the heavy load. Alright, so performance comparison. So we are going to compare four PCs together, and compare which one is more their performance is more higher. And lastly, we are going to do the data analysis and report. Alright, so for the scope of this project, we're going to use four benchmarking tools, as I said before: CPU Z, Geekbench, Mini Tools Partition Wizard, and the Windows Task Manager. We're going to compare four different computers with their outcome, with their scores. After that, we are going to analyze the impact of different workloads and on the CPU performance. We create three situation, multiple situation for the CPU to test their performance and their memories, how the memories works, their usage of memories, and after that, we're going to use the complete compilation of benchmarking result and comparison of CPU performance. So we are going to use their result to compare their to see what's the relationship of the CPU with their CPU's performance. Right. So right now we're going to benchmarking execution. So I'm going to first I'm going to for mine I'm going uh, to do the benchmarking for my computer, which is the MSI GF6611 UD. So we are going to use CPU Z to study the CPU's specification. Alright, so this is the CPU Z basically. Is we can see every data of the CPU mainboard memory, their memory slot, their graphic, batch, and everything. So for my uh, MSI GF6611UD, you are using the processor name Intel Core i7 11800H. So it will use the max TDP 45 watt using 10 nanometer technology. It runs at the maximum speed at the 2.3 gigahertz, and we can see it has three level of cache. So for the first level of the cache, the level 1 cache, we have 48 kilobytes of the level 1 data cache. So for the uh, installation cache L1, we have 32 kilobytes. We have 8 of them. Alright, so for the level 2, we have 1.25 megabytes, also 8 of them, and one level 3, 24 megabytes. Right, so right now we can see the main board of the computer. It uses the motherboard is manufactured by the Microstar International company. The model is MS1582. So usually it's using bus specs of PCIe 4.0. So basically it's 16 GT per second. Alright, now we're going to see the memory. So we can see it uses DDR4 with 16 gigabytes. So this basically the computer have 16 GB of RAM. Right, so we're going to the next computer. Alright, so let's come to the benchmarking for the CPU. We are going to use Geekbench 6. For the first computer, MSI GFC611UD, we're going to use the Geekbench 6. Alright, so as you can see, wait a second. So this is the what we call this is right. So this is the Geekbench 6. Right, so this is the Geekbench 6 of uh, the interface of the Geekbench 6. So we can see, as you can see, the CPU information is the i7 11 Gen 800H. So basically it has 8 core and 16 thread. base frequency at 2.3 gigahertz and maximum frequency at 4.6 gigahertz. Alright, so basically after we run the CPU benchmark, we have the result. We will have the result of the CPU. Right, so as you can see, this is the computer names, and for the single core score we get 1992 scores, and for the multi-core scores we had 8500. Alright, so is for the system information and the CPU information. This is as the same as it's the same as the CPU Z. We have L1 instruction cache of 32 kilobyte of 8 words, and data cache level 1 data cache of 8 words of 48 kilobyte, and level 2 cache have 8 words of 1.25 megabyte, and so on. And lastly, we have the 24 megabyte with one word. Wait a minute. So as you can see, we have the memory information of 16 gig of RAM, the memory of 16 gig, and the transfer rate is 3200 MT per second. So with the DDR4 static dynamic RAM with 2 channels. Alright, so we have the file compression, which is done at the rate of 274.1 megabyte per second, and the navigation 9.76 routes per second. For the HTML5 browser, 41 pages per second. PDF rendering with the 47.5 megapixel per second, and the photo library 26.6 image per second, and the clang 9.56 clickness per second. Text processing 150 pages per second. SS compression 62.8 megabyte per second. Object detection 57.58 image per second. Background blur with 10 image per second. Horizon detection with 81 megapixel per second, and object remover 133 megapixels per second. HDR for the video is 56.6 megapixels per second, and the photo filter 23 image per second, and the ray tracer we have 1.85 megapixels per second structure, and lastly for the structure for motion is 68.8 kilopixel per second. So this basically is the performance of the main of the single core. Single core means the big core of the performance of the CPU. So for the multi-core, it has their performance is much higher than the single core, as it uses every single core to do the task. So basically, we have the total mark of 8500. So for the multi-core, we have file compression of 600 something megabytes per second, navigation 63.1 routes per second, browser 165 pages per second, PDF render 260 megapixel per second for the library, 157 image per second, clang 64 clients per second, text processing 190 pages per second, asset compression 430 megabytes per second, object detection 150, and then lastly we get 8522. Alright, so this is for the Geekbench 6.
Alright, so Assalamualaikum. My name is Muhammad Hafiz. Now I would like to present about the Minitos partition wizard using my laptop, which is Acer Nitro. This is the model name. Okay, so for partition wizard, okay, this is it. So as you can see here, this is for the sequential. Okay, this is for the sequential, and right. So as you can see, the transfer size is up to 4 kilobyte, 8, 16 and also 32 kilobyte. Okay, this is for the transfer size, and at the x-axis, the horizontal one is the transfer speed, which is in megabyte per second. So as you can see here, the green bar is representing the sequential writing, while the blue bar is representing sequential reading. Okay, so you can see here 32 kilobyte. The speed is 32 kilobyte for the writing. The speed is up to 3081 megabyte per second, while for the reading is up to 2300 megabyte per second. Alright, so and so on. Okay, now we want to test about the random disk performance. Okay, so as you can see here, is testing the disk. So the bar will pop up one by one. This is for the 4 kilobyte. Now it will test for the 8 kilobyte. You just have to wait. Alright, the orange bar is for the random reading. It will now test. Okay, it will now, as you can see, the purple bar is representing the random writing. The orange is the reading, the purple is for the writing. Okay, so 4 kilobyte and 8 kilobyte also have done testing. So as you can see, for 8 kilobyte, the speed is up to 2375 megabyte per second. 16 is up to 2000 for the 16, and the random writing, the purple bar, up to 2700 megabyte per second. Okay, so for the 32, random reading is 2800 megabyte per second, and the writing 2700. Okay, so that is as you can see here, there's the queue number and also thread number. Okay, so I think that's all for the partition wizard. Thank you. Alright, so now I will explain about the task manager using my laptop. Okay, so this is for the low load. Alright, so this when I open only one application, which is Microsoft Word. So as you can see here, the percentage, my total memory is 16 GB for the RAM. So after I open Microsoft Word, the total storage use is 57%. Alright, so available only 6.8 GB. Okay, so now as you can see here, this is the detail. So NitroSense is for my laptop gaming driver, consume the most, and anti-malware also consume the most. And so as you can see here, Microsoft Word only consume 2.5% out of my total RAM, random access memory. Okay, so this is for the low load, only 57%. Okay, so this is for the medium. Alright, so for the medium, I open Google Chrome, a lot of tab, and also Windows Explorer, WhatsApp, Microsoft Excel, and also Microsoft Word. So each of them consume 2.2%, 2.4, 3.4. So but the most consume is my gaming driver, which consumes 6.9%. So the total, after I open a few more application, for example like 4 to 6 application, now there it consume a lot more memory, random access memory. For the low load 57, now for the medium is 62. Alright, so for the high one, high load I open more to gaming, because game it consume a lot of RAM. So I open Steam, Discord. I also open Epic Game Launcher. So I can see here the Steam consume the most, 8.4%. So the total RAM that I use is 7.772%. Okay, see here 7.4. Available only 4.1 gig. Alright, so based on this we can prove that the more application we open at the same time, it will consume more RAM in our in our laptop, in our device lah. So after that, I think that's all for task manager. Alright, for the high load, that's all for the task manager. Thank you.
So good day, everyone. My name is Kwan. Today I will be responsible to explain about the part 2 of our project, which includes us running a assembly code to test our CPU execution time. Okay, so the equation given in the header message here says benchmark CPU time using equation y equals 3x cubed plus 4x squared plus 18x plus 22. So why is it the coefficients like that? Is because we chose the day of the birth date of the group's teammates. Okay, next, the equation uses a coefficients are the delay factor, and x is the integer input values. It implements a loop that iterates different loop types, with each time calculating the value of y for a different x value. So different loops will represent different load that will impose to the polynomial equation as a benchmarking method. We measure the time taken to complete the different loop, and then the results is tabled for the purpose of comparing between our laptop. So we assume that the input x values are consecutive integers starting from 1, the value of max defined looping, and okay, the polynomial is given where the x is an input integer value between 1 and the max loop and so for the defined delay factors, which is our coefficient, is defined as coef1, coef2, coef3, and coef4. The sum, this is our capture milliseconds before executing the loop. And then this is the after. This is CPU execution time, which is defined as 0. All of these are type keyword. So for the main code, we start off with printing the separator. Then we print out our message of new line. And then we write a string, which is a new line. This is a new line. The next, then we output our welcome message, which is welcome the CPU benchmark program. Then we write a message to give the user an input prompt so that we can define our loops, max number of loops, that is n. Okay, and then we output to tell the user that the stress test is being done. And then we call the library function, of Win32 library function, get milliseconds to capture start time for the CPU. Then we use a loop. Okay, we first initialize the sum before each calculation. This is the core of our assembly program. We implement the function, polynomial function y. Okay, so next we multiply. This is the multiply function. Multiply opcode. And then we add the delay within the loop where the condition is jump, not 0. We delay the loop. Then we accumulate the result in the sum variable. Then we move on to our loop. Then we compare the loop counter. If it will jump if less than or equal to the loop count. Then after that, we capture the time after completing the equation. Then we use that to calculate our CPU time, execution time, then store it inside the variable CPU milliseconds, and we display our result. Okay, next, we write the first cap message, which is the first capture execution, and then the second, and then the difference between them. Then we take the value of sum from the equation. Then we tell the user, we ask the user whether they want to continue the stress test. If yes, it will jump equal to y, it will jump back to the start of the loop, then carry out the stress test again. If not, it will exit the program. So I'll try to run the assembly code. This is output. Here, after running the assembly code, we first input the value of n, where n equals 50. You can see here, this is the first capture time and the second capture time, and then our CPU time, which is the difference in capture time. Then we move on to the next n value, which is 100. The next 400. The next 500. About 100. And then 1000. Okay, so this is the output after running the multiple loops. And so that it is for the assembly coding part, for the part 2 of the project. And then we'll move on to the comparison and discussion for the results of different platforms. And then I'll hand it off to my teammate. And that's all. Thank you.
So now I'll be presenting our benchmark for the CPU clock frequency speed. So among all of our PC, the Asus desktop has the highest clock frequency at 4588 MHz, which means it has a superior performance in single-threaded tasks. Next, we got the Asus Nitro, which also has a strong clock frequency at 2394 MHz, which is suitable for both single-threaded and multi-threaded applications. And the next one, we got the MSI laptop, which shows a decent clock frequency at 1596 MHz, which means it's good for general tasks. And lastly, we've got the ROG Strix, which has the lowest clock frequency at 1296 MHz, which might negatively impact its performance in both single-threaded and multi-threaded tasks, but by no means it's a poor performance. Next, we got the cache size. So Asus Desktop has the largest cache size across all levels for the L1, L2, and L3, which means it has a significant advantage in terms of the cloud retrieval speed and overall performance. Next, you got the MSI and ROG, which have respectable cache size, especially in the L2 and L3 cache, making them a good performer in tasks that benefit from larger cache. Lastly, you got the Asus Nitro, which has the smallest L3 cache size, and it will impact its performance, especially in tasks requiring frequent data access. The third one, you got the memory, and fortunately, all models are equipped with 16 GB of RAM, ensuring a level playing field in terms of memory capacity, and it is adequate for most applications and multitasking scenarios in most cases. Then lastly, we got the motherboard. For the Asus desktop, we use the Asus Tough Gaming H670 Pro Wi-Fi D4. It's a high performance motherboard, and it's most likely optimized for gaming and demanding tasks. The next RG Strix, it's a different motherboard, the G614JB, but it's also oriented towards gaming and high performance usage. For the MSI, it's equipped with MicroStar International MS1582 motherboard, which provide a solid performance for general and gaming tasks. Acer Nitro utilizes the RTL Sportage_RTH motherboard, which is sufficient for standard tasks, but it may not match the performance for gaming-oriented motherboards such as others does. Now we'll do the comparison. So at the first place, you got for the CPU performance, we got the Asus desktop, which leads in the CPU clock frequency at staggering 4588 MHz speed, which made it the top performer for both single-threaded and multi-threaded tasks, and it's followed up by the SC Nitro, and it ranks second. Then we got the MSI with a clock frequency of 1596.10 MHz, and it is the third performance. Then lastly, you got the ROG Strix with the lowest clock frequency, and it is underperforming in comparison to others with the clock speed 1296 MHz. For the memory and multitasking, we got all the computers have 16 bits of memory, which means they are all equally suited for modern multitasking and memory-intensive applications for PC nowadays. Then we got the motherboard and data transfer speed. The RG6 motherboard support the fastest data transfer speed alongside with the SSD top with the PCI Express 5.0, and it gives an edge in the tasks requiring a high data transfer rate. While the MSI and the Nitro Pro motherboard supports the PCI Express 4.0 with similar data transfer speed, but it will not match the performance of PCI Express 5.0. Next, you got the Geekbench benchmark. So the Geekbench benchmark, we got the single core score, and the Asus desktop achieved the highest single core score at 2400 footage, which means it's the perfect for tasks that require a good single track performance, such as web browsing, office applications, basic photo editing, and gaming. The second highest single core we got the MSI at 1992, and it, it is also a solid score, and it provides a good performance for every task, but it's not as good as the SSS store. The third one we got the it's a moderate single core score at 1334, and it's sufficient for general use, but it may lag behind in single threaded applications compared to the other two. Lastly, we got the lowest single core score for Acer Nitro at 1191. It is likely to be slow in single threaded applications than the other system, but it's best suited for basic tasks. Next, we got the multi-core score. The SS desktop again is the highest multi-core score at 1436, which means it excels in the multi-threaded tasks such as video editing, 3D rendering, software development, and heavy multitasking. Next, you got the RG-Strix E6 for TV. It's also a strong multi-core score at 10,786, and it handles a lot of multi-threaded applications and offers a good performance. The third one, we got the MSI. It has a decent multi-core score at 8,552 and is capable of managing multi-threaded applications, but it's not as good as the other two. Then we got the lowest multi-core score for the Acer Nitro at 4,862, and it may struggle with highly multi-threaded tasks and is less suitable for demanding applications. For the comparison, we got the SSS top, which is best suited for users in needing top-tier performance in both single-threaded and multi-threaded tasks. It delivers the most fastest speed and fastest experience across a wide range of applications from web browsing, Facebook to gaming and video editing. Next, you got the MSI. It's a balanced performer handling both single-core and multi-core tasks well, and it is suitable for users who need good performance across various applications. Next, you got the ROG, and it is more suitable for general tasks and moderately demanding applications. And lastly, you got the Acer Nitro, which is more appropriate for basic tasks and less demanding applications. Although it provides a lower performance in single and multi-core tasks, it is ideal for users with less intensive computer needs. Now we got the mini tools, and we benchmark our sequential and random data transfer size in both reading and writing. So for the sequential transfer size, you can see that the Asus desktop deliver the best performance for the transfer size on both reading and writing operations, which means it has a superior disk performance. Next, we got the Acer Nitro, which excels particularly in writing operation, especially in larger transfer size, although its reading performance for smaller size is comparatively lower. The third one got the RG Strix, which provides a moderate overall performance with decent reading and writing speed, but does not lead in any specific category. For the MSI, it generally exhibits the lowest performance in both read and write operations across all transfer sizes, which means it has the slowest disk performance among the four systems. For the random transfer size, again, the desktop consistently deliver the best performance across most random transfer size for both reading and writing operations, which means it also has a superior disk performance. The Acer Nitro excels particularly in writing operations, especially with larger random transfer size, and also performs well in reading operations. For the RG streets, it provides a good overall performance with strong reading and writing speeds, but does not lead in any specific category. Lastly, MSI will generally exhibit the lowest performance in both read and write operation across all random transfer size, which means it has the slowest least performance among the four systems. So for the comparison, the SS stuff leads in both sequential and random read or write operations, making it the best performer for this intensive task. Meanwhile, the SL Nitro follows closely SLA, particularly in writing operations and performing well in reading tasks. The RG provides a good overall performance with strong reading and writing speeds, but does not lead in any specific category. And lastly, you got the MSI, which lags significantly behind, which may indicate struggle with tasks that require efficient disk operations. While all systems show a drop in performance from sequential to random operations, the SS stuff the stock indicates strongly in both scenarios, and the SQL Pro follows with a robust performance in both types of operation, especially in larger transfer files. The ROG performance drop is probably a bit noticeable, but it remains moderate, and the MSI shows the weakest performance highlighting potential bottlenecks in its storage system. And lastly, you got the task manager. For a task manager, it shows we did a 3 test, which is low load, medium load, and high load. So here we can see that the stuff desktop has so in here we can see the SS stuff desktop had exhibits a gradual increase in memory usage from 8% to 56%, which means it is balanced in efficient handling of tasks without rapidly approaching its memory limits. Meanwhile, the RG Strix shows a steady increase in memory usage percentage from 40% and under low load and to 60% under high load, which means it's efficient resource management is scaling. Next, you got the SL Nitro, which starts at a high memory usage of 56% under low load and then rise to 74% under high load, suggesting it is operate closer to maximum capacity more frequently. Next, you got the MSI. It shows a significant increase in memory usage percentage from 59 to 72%, which means it a bit efficient in scaling but has a tendency to reach a higher usage under heavy loads. For the memory performance, the SS Stuff desktop uses between 6.1 gig and 8.9 gig of memory, which means it has a moderate memory utilization that scales efficiently. And RJ Strix plus also 6.1 gig under low load to 9.4 gig under high load, which means it has a higher overall memory capacity in effective scaling. Got the SN Nitro, which consumes the most memory ranging from 8.7 gig to 11.6 gig. Then lastly, you got the MSI, which uses the highest amount of memory from 6.7 gig under low load to 11.8 gig under high load, which means it is well equipped for probably intensive applications. Now for my reflection. So this project taught me how to benchmark my PC and my PC CPU using tools like CPU-Z, Bench, Unification tools, and Task Manager. Not only my CPU but also my memory speed, my transfer and reading data speeds. The benchmarking process improved my understanding of interpreting various PC specifications, including speed, clock speed, memory speed of different storage disks for all drivers. And analyzing this project has improved my decision-making skills, particularly when considering PC upgrades to ensure sustained performance and efficiency.
My reflection is that this project lets me explore various benchmarking tools such as CPU-Z, Minitools, Partition Wizard, and then Geekbench 6 to measure metrics like processing speed, memory, access times, and I/O throughput. This project also emphasized the importance of interpreting benchmark results within context. We cannot just view the raw numbers, but it is crucial to consider factors like the workload type and applications as well when drawing conclusion about the relative performance of different computers. So from this project, I also gained the experience in critically and evaluating the performance claims of various computers. So in the future, I might be interested in exploring how benchmarking methodologies can be used to further refine the search for optimized computer architectures for specific tasks such as machine learning or high performance computing. Okay, thank you.
Alright, so now I want to explain about my reflection towards this project. Alright, so in my opinion, this project it will help me to learn a lot of new things. For example, like how hardware specification will affect the system performance by using tools like CPU Z, Geekbench, and also Partition Wizard. And also next, it will give me experience hands-on and show me how different component and configuration directly impact speed and efficiency, which means like different laptop have different specification and different component, and it will impact the laptop or the device, impact the speed. The higher the cost of the component, the higher the speed and the efficient of the components. Alright, so next, this experience helped me to make a better decision when it comes to optimizing or selecting the hardware for diverse computing needs. Alright, so later on, if I want to change a new laptop and so on, it will help me to make a better decision in term of cost, the performance of the laptop, the speed, the efficiency, and also each of the detailed specification of the laptop. Alright, so that's all for the reflection. Thank you.
All right, so for the next part, for the reflection of my computers after benchmarking and observation on the MSI GF6611UD benchmarks, we have the quite remarkable stability for the computer. So it has not the best performance among the four computers, but we have the quite outstanding performance and stability. So for the performance consistency, we use different benchmarking tools using Geekbench 6 and Mini tool scores. All computer all computers show the same performance in but all the computers shows the same performance in ASM assembly code benchmarking. Um, Even though there is a difference in the benchmark score, so there will be no how we say no like obvious like we can feel the performance difference between four four computers. So for the efficiency, we have the consistent capture times highlight the efficiency of the assembly code. So it can handle the assembly code with the difference at 0 millisecond. This is quite impressive for four computer CPU stress. So every 50 loops, 50 loops, 100 loops, 200 loops, 500 loops, 700 loops, and 1000 loops, we can see that every computer has the same efficiency. So for the next part, we're going to the reflection of the next part of the next computer.